Since the dawn of humanity, we have gazed at the sky, our eyes drawn to the shimmering stars, our dreams reaching beyond the boundaries of Earth. Mars, the red planet, has captured our imaginations like no other world, stirring visions of exploration, adventure, and the possibility of new beginnings. Yet for all its allure, Mars hides a secret. A silent adversary, unseen but formidable, waits to challenge us at every step. This is the story of radiation on Mars, a force that transforms hope into a struggle for survival. Unlike Earth, which is shielded by a mighty magnetic field and a thick, life-protecting atmosphere, Mars stands exposed. Stripped of its global magnetic armor, with only a thin veil of atmospheric gases, the surface of Mars is laid bare before the relentless assault of high-energy particles streaming from the cosmos. Billions of galactic cosmic rays, known as GCRs, rain upon Mars in a never-ending storm. They are the chronic threat, a steady barrage that quietly accumulates damage day after day, year after year. Yet Mars faces more than just this slow poison. Occasionally, the sun erupts with sudden fury, releasing solar energetic particles, SEPs, into space. These bursts are acute and unpredictable, capable of delivering lethal doses in mere moments, threatening not only missions, but the lives and minds of those who dare to venture out. When these energetic particles strike the Martian surface, their violence does not end. Instead, their collision with matter creates deadly echoes. Secondary radiation. These cascading particles weave through habitats, equipment, and even human bodies, complicating the challenge of shielding and safety. The lack of a natural barrier means that Mars is a world where every moment is spent under siege, where the very ground beneath our feet is a battleground between life and the forces of the universe. Consider the plight of astronauts tasked with journeying to this alien world. The International Space Station orbits Earth, protected by our planet's shields, yet even there, radiation is a concern. On Mars, the danger multiplies. Astronauts may be exposed to doses up to 2.5 times higher than those experienced aboard the ISS. Over time, these doses accumulate, increasing the risk of cancer, damaging organs, and perhaps most insidiously, attacking the central nervous system. Imagine a crew member entrusted with critical decisions and complex tasks, slowly losing cognitive sharpness, memory, and judgment. The threat is not only to the body, but to the mind itself, a scenario that undermines the very core of exploration. Yet the most hazardous period for Mars explorers may not be on the planet's surface, but during their voyage through the void. The journey from Earth to Mars lasts 6 to 9 months, a time when the protective cocoon of Earth is left behind and the spacecraft is battered by cosmic rays and solar storms. During this interplanetary passage, radiation levels soar, nearly 3 times higher than those on the Martian surface. The ship becomes both sanctuary and exposure chamber, as every crew member faces the highest risks of acute and chronic radiation. Technology fares no better in this hostile environment. High-energy particles can pierce the delicate circuits of computers and spacecraft systems, triggering single-event upsets, momentary errors that can corrupt data, disrupt operations, or even destroy vital components. As electronics become more compact and sophisticated, they also grow more vulnerable. Each particle that slips through the shielding is a potential saboteur, capable of undermining years of engineering in an instant. Faced with such daunting odds. Survival on Mars demands ingenuity, a multifaceted strategy to defend against the invisible enemy. Carrying heavy shielding from Earth is impractical, so the best protection may be found right on Mars itself. The planet's regolith, the rocky soil covering its surface, is a natural shield. Just 1 meter of this material can halve the exposure to harmful radiation. Future Martian habitats will likely be built underground or covered by thick layers of regolith, turning the planet's own resources into a bulwark against cosmic threats. But physical barriers are not enough. Solar energetic particles strike without warning, and when they do, astronauts need places of refuge, storm shelters reinforced with water or specialized shielding, where they can wait out the tempest. These sanctuaries must be woven into every habitat and vehicle design, ready to offer protection at a moment's notice. Science continues its quest for further defenses. Researchers around the world are developing pharmaceuticals that might mitigate the effects of radiation, medicines that could repair or protect cells from damage. Advanced health monitoring systems will track exposure in real time, alerting astronauts and ground control to hidden dangers and offering a last line of defense when all else fails. Radiation has altered the very nature of our search for life on Mars. The surface is relentlessly sterilized that any living organisms, past or present, must have retreated underground, shielded from the unending assault. The quest for Martian life has shifted from the plains and craters to the hidden depths, where water, warmth, and protection might still nurture the spark of existence. Drilling into the planet's crust, exploring caves and tunnels, our technology must evolve to meet the challenge, venturing into realms never before touched by human hands. In this struggle, radiation is not only a barrier, but a measure of our resolve. It compels us to rethink how we build, how we travel, how we survive. It forces us to innovate, to adapt, and to persevere. The journey to Mars is a journey into peril, but it is also a testament to the spirit of exploration. Each obstacle overcome brings us closer to a future where humanity is not bound to one planet, but spreads across worlds, writing new chapters in the story of life. Mars, invisible adversary, tests our ingenuity and our endurance. It demands courage, collaboration, and relentless pursuit of solutions. If we can master this challenge, if we can build shelters from Martian soil, create medicines to heal our bodies, and craft machines resilient against the cosmic storm, then we would have proven ourselves worthy of this new frontier. In facing the radiation of Mars, we confront the very limits of our technology, our biology, and our imagination. But with every advance, every discovery, and every step forward, hope grows stronger. The Red Planet may be a realm of death and danger, but it is also a land of possibility, a stage for humanity's boldest dreams. This is the test of Mars, not just a problem to be solved, but a crucible in which our ingenuity and perseverance are forged. Only by overcoming its invisible trials will we earn our place among the stars, becoming, at last, a multi-planet species. And in that achievement, we take the next step in the grand adventure of humankind, reaching out into the infinite with courage, hope, and determination.